Hello, today we are going to be demonstrating and explaining the physics behind jumping on a trampoline.
First, we want to show you all of the main components of a trampoline. There are steel tubes, a jumping mat, a frame pad, a safety net, bolts and connecting T-anchors, and of course, springs. Notice how there are no electrical components that allow the trampoline to function whatsoever. It is simply made to work mechanically and by the power of physics. So let's get into it.
Newton's first law of motion states that an object at rest remains at rest, and an object in motion remains in motion at a constant speed and in a straight line unless acted on by an unbalanced force. Have you ever jumped on a trampoline? If so, did you go flying into the sky? I didn't think so. That's because the unbalanced force of gravity acting on the force of your body being propelled up after jumping against the springs stop you from flying into the air and keeps your body on Earth. The same goes for the reason why, while your force is acting on the jumping mat, it's not ripping right through. That's because the unbalanced force of the springs react and push your force in the opposite direction.
To gain a better understanding of this, let's take a look at the free body diagrams. When propelling up into the sky after jumping down against the springs, the unbalanced force of gravity is greater than the normal force. This is what keeps your body on Earth instead of continuously propelling off into the sky. Now, when the force of your body is on the jumping mat exerting against the springs, the unbalanced normal force is greater than the force of gravity. Again, this explains why you're not ripping through the mat. Now let's talk about the potential and kinetic energy. The potential and kinetic energy can clearly be seen here while Dylan is jumping up and down, and as a matter of fact, it changes throughout. While Dylan is at his maximum height, his potential energy is maximized, while his kinetic energy is 0. However, as his body is falling down towards the jumping mat and then back up, his kinetic energy is increasing and decreasing with his velocity. The kinetic and potential energy is not only observed while he is jumping though. Whenever Dylan is at his minimum height, his potential is maximized here as well, and his kinetic energy is 0. Then, as his force releases back into the air, his kinetic energy is once again increasing and decreasing with his velocity. This transfer of energy between kinetic and potential can also be considered as a perfect example of the conservation of energy.
Hooke's law is another principle that can be observed while jumping on a trampoline. When Juliet is exerting force onto the jumping mat while falling down from her maximum height, the springs are stretched to the exact same magnitude of force. Once reaching that equilibrium of force, the springs will return to an equilibrium once again of 0, since there is no longer a force being exerted against the springs.
As you can see, there are various principles of physics behind such a simple daily activity like jumping on a trampoline, like Newton's laws of motion, the conservation of energy, and Hooke's law. So next time you're jumping on a trampoline, think about how it wouldn't even be possible without the power of physics. We hope you guys enjoyed watching just as much as Dylan and I enjoyed making this video.
Thanks for watching, bye!